Can you still see me and see the presentation?
Yes,
Okay.
the
Good.
first page. Now data is new oil.
All right. Thanks. Thank you. So I love this phrase. Now I know it drives a lot of people nuts, and there's a lot of haters on data as a new oil. Oh, data is not oil. You can't put it in my car. I can't burn it to heat the house. But people who downplay this phrase miss the significance of what this is inferring to organizations. Is it in the same way that oil was the fuel that drove the economic growth in the 20th century? Data is going to be that catalyst that drives the economic growth in the 21st century. When you start thinking about data as an economic asset, then it forces organizations to think differently about how they're approaching the data and analytics conversation. And in fact, if you believe that data is the new oil, that data is the catalyst for the economic growth in the 21st century, then every organization needs to start by asking themselves this really important question. How effective are we at leveraging data and analytics to power our business models? Now think about it. There's a very simple question that every executive, every manager, every vice president really needs to think about. If we believe that data is this economic asset, the source of growth in the 21st century, then understanding how effective you are has to be job one for any executive. And so what we've learned through a bunch of research at University of San Francisco and some talking and working with customers is that clients, organizations tend to sit along one of 5 different points along this data and analytics business model maturity. I want to emphasize the business model maturity. It's not a maturity of how good you're using technology, how good you are at TensorFlow or Python or SQL. The technology is only an enabler. It's like having a tool, having a hammer. Having a hammer doesn't make you an architect. It doesn't allow you to build a house. There's so much more to it. And we get fixated on the tools when in reality, we need to talk about how are data and analytics impacting the business model. And so again, we find organizations sit along one of 5 different points on this maturity model. And by far, most organizations today simply use data to monitor the business. They use it for operational reporting. They use it for management dashboards, to produce reports and dashboards that tell them what happened, to provide a retrospective view of the business. Nothing wrong with that, but you're not predicting, you're not prescribing, you're not automating, you're not creating autonomous. If you're only focused on using data to tell you what happened, that's like driving a car using a rearview mirror. We need to help organizations traverse this maturity model. And the way to do that is we have to first and foremost overcome this analytics chasm. There's a chasm that prevents organizations from crossing over and becoming more predictive, more prescriptive. It's not a technology chasm. The way to cross that chasm is to use what I call nanoeconomics. Nanoeconomics is the economic theory of individualized predicted behavior and performance propensities. We need to get down to the granular level by use case to jump over the analytics chasm. Use the economics of data and analytics to help us to uncover the customer, product, and operational insights, these predicted behavioral and performance propensities that are buried in the data that I can use to prescribe actions in order to optimize my business and my business processes. But there's even more here. As I'm learning more, gaining more and more insights about my customers, my product, my operations, it allows me to start to monetize not the data, but the insights about my customers, about what new products they might want, how I might reach them, how I can create new pricing models, new channels, right? There's insights about my customers, my products, and my operations that can drive new monetization opportunities. But it only comes when you started in the first 2 or phases 1, 2, and 3 to start focusing on uncovering those insights in the business insights phase and using those insights to optimize your internal operations. The 5th stage is the nirvana. It's nirvana. It's the holy grail. And it's the holy grail because you'll never get there. Let's be really clear. Digital transformation is something you're never going to reach. I hate the word digital because digital is the wrong term. It should be called cultural transformation. Heck, maybe I should change this. Because what it's about It's about creating an organization from both the analytics and a human perspective that can continuously learn and adapt. That's what transformation is about. And it's caused, yes, sometimes by digital. We're seeing it in the pandemic. We're seeing it in the climate change. We're seeing it in social unrest. We're seeing transformation being the new norm. And any organization that wants to survive in a world where transformation is constantly happening has to have both the machinery through analytics and the human empowerment that allows the organization to continuously learn and adapt. That's what transformation is about. Now, in order to do this, if you believe that your organization is prepared to do this, and by the way, it's no short order, because we're going to ask you to change how you think about your business. We're going to change how you think about data and analytics, and we're going to change how you think about your employees. If you want to do this, the way to attack this problem is something we call the value engineering framework. And if you want to derive and drive value from your data and analytics, if value creation is what you seek, then you must start with where your organization and how it creates value. How does your organization create value? Think about the university. You create value by how you recruit students, how you retain students, how you offer scholarships, right? You create value in a number of different ways. And by the way, you have KPIs and metrics against which you're going to measure how effective you are at creating value. That's the starting point. The data and analytics starting point isn't with data. It isn't with analytics. It isn't about becoming data-centric. It's about becoming value-centric and understanding how the organization creates value and what are the KPIs and metrics against which you are going to measure progress and success. Then what you want to do is, once you understand how the organization is trying to create value, you need to bring in a broad perspective of stakeholders who are trying to help achieve that. These are the people or the organizations who either impact or are impacted by this business initiative. And it's important to bring them all in because you want a broad range of perspectives of how they're trying to achieve this. What are their win conditions? What are the KPIs and metrics against which these stakeholders are trying to measure progress and success? Hint, if you don't do this right and you build your AI models, you risk confirmation bias in your AI models. The way to battle confirmation bias in your AI models is to have a broad range of perspectives, not opinions, but a perspectives of how people are trying to drive value and the KPIs and metrics against which you're going to measure success. Once you've identified the stakeholders and the KPIs, the real power of this process is around identifying the decisions you're trying to optimize. Now, the beauty of decisions, I love decisions. In fact, I think I'm a little red circle around this. This is the secret sauce. It is around decisions. Here's why decisions are powerful. Number one, they're easy to identify. Every business stakeholder in the organization knows what decisions they're trying to make. They've been trying to make them for years, decades, maybe generations. So number one, decisions are easy to identify because the stakeholders intimately know them. Number two, decisions by their very nature are actionable. They're not questions, which are useful about driving inquiry to understand, but decisions are actionable. Number three, why I like decisions. I can attribute value to decisions. If my decision is how do I retain more of my freshmen, how do I do a better job of predicting unplanned operational downtime, right? If the decisions have value. And the final thing about decisions is I can optimize them with data science. Here's the thing. For the most part, decisions haven't changed, I said, for years, decades, generations. What's changed are the answers. We've now had the ability to not make decisions based on averages. We now have the ability to make decisions based on the individual behavioral and performance propensities, nanoeconomics. And once you've understand the decisions, once you've gone through a process to identify, validate, value, and prioritize your decisions, then everything else falls out. What analytics do I need to build? What data do I need? How am I going to instrument my system? What architecture and technology am I going to need? Everything else falls out. Once you understand, identify, validate, value, and prioritize the decisions, everything else falls out. But unfortunately, you probably know, everybody likes to start the conversation with a shiny object at the bottom. Oh, look at TensorFlow. Look what I could do. That's not where to start. Architecture and technology are there to serve the value creation process. They are not in of themselves the value creation process. So let's talk about nanoeconomics. This is a concept that I came up with and trying to sponsor and trying to drive. And I want you to understand why nanoeconomics and data science go hand in hand. So we know we have this thing called an economic value curve. An economic value curve measures the impact that independent variables have on a dependent variable. In this case, let's say I'm a theme park in Orlando, Florida, and I'm trying to keep my rides up and going, because if my rides, my attraction, if my new Star Wars ride isn't up and running, I am losing money. So what I'm going to do is I'm going to spend more and more money on maintenance to try to increase uptime of my rides. This is true for hospitals or manufacturing plants or energy plants, whatever it might be, right? So, but at some point, what happens is the more that you spend on maintenance and all the factors that go into maintenance, the less of an improvement you give in uptime. That's called the law of diminishing returns. It's just a fact, right? The more you spend, the less you get back. And actually, at some point, you can actually overspend and overcrowd out and actually have it go the wrong direction. This is a fact. This is an economic fact, the law of diminishing returns. Well, how do we address this? How do we overcome the law of diminishing returns? How do we learn to do more with less? Well, by leveraging nanoeconomics, we can get down to a very precision point. So we know exactly what part to replace, when to replace it, who should replace it, what are the consumables I'm going to need, what are the inventory am I going to need. Think about all the decisions that we make today based on averages. And now I can get down to very precision on humans. What customers are most likely to leave? When are they likely to leave? What are they likely to respond to keep them? How valuable are they in influencing others? I get down to the very individual, so I spend my dollars in the most efficient way. Direct marketers have known this for years. But now we're seeing this whole idea of using concept of nanoeconomics to apply to this idea of driving very granular decisions. And I like to talk about, we talk about big data. It isn't the volume of data that's interesting. It's not the volume of data I'm going to monetize. It's the granularity. For every human, I can understand their propensities and passions and interests and preferences and behaviors and tendencies and relationships. And I can use that to make very precision decisions. But it isn't just humans, by the way. I can do this for wind turbines, jet engines, compressors, elevators, escalators. It isn't just humans that have behavioral propensities. So do devices and things. And it is around these humans that I'm going to apply this concept of nanoeconomics to drive very precision action. I'm going to leverage data science to make not decisions based on averages, but decisions based on individual propensities. And I'm going to create something called an analytic profile, sometimes called an asset model, where I'm going to collect all the individual propensities. Here's an example of one for my healthcare profile, right? It's got a series of scores that have been created through data science, a diet score, an exercise score, a stress score, a wellness score. My doctor recently told me I need to lose 20 pounds. So I guess my diet score was going down here. But it also has a bunch of at-risk scores, like my risk of dying from having a heart attack, having a stroke. What's my at-risk of catching COVID? Now, the COVID pandemic has been exacerbated by our inability to make precision decisions. We've made decisions about who should get shots, who should be wearing masks based on averages. And averages only work for the average person. Let's be really honest. No one's average. And so what's happened is we have caused this pandemic to extend itself because we haven't taken a very focused data science approach to understanding who are the people most at risk, who are the ones most likely to catch it, who are the ones most likely to spread it, and then taking precision actions to get those people vaccinated. This falls on us for our inability to use data and analytics to make smart decisions. And as a result, we have thousands of people dying because we're inefficient and stupid about how we use data and analytics. And by the way, one last step here on this economic value curve, you can see how poor the US is at leveraging its economic value curve. You can see how the US is spending more and more money on healthcare, and the results as measured by life expectancy is flattening out. But again, we have the opportunity to apply nanoeconomics to all the wealth of data we have about individuals and diseases and treatments and hospitals and such to create things like precision medicine and personalized welfare and diagnostic therapy. All these things on the left, all these things that can have huge impact and could transform our economic value curve for not just the US, but for the world. These things on the left are all doable if we think more precise about how we leverage nanoeconomics and these predicted individual and device propensities to transform the business, to do more with less. We kind of talked about this earlier before we started the presentation about how important it is that we teach everybody data literacy. And I'm not just talking businesses. This has become a very strong mission of mine as I teach in the university. When I teach universities, and I'm even talking to high schools now, how do you help students, peoples, tomorrow's leaders to understand how important it is to understand about data? Well, what is it we're trying to do? Right. The first thing is we need to understand what data science is. And data science is very simple. It's very simple. Data science is about identifying variables and metrics that might be better predictors of performance. Period. That's all it is. You don't need to buy a 600-page book to figure out what data science is. We're trying to find those variables and metrics. Now, the key point here, the key word in that statement, which isn't hard to figure out because I got it in blue and underlined and italic, is the word might. The data science process, like any good science process, is a process full of exploration, trying, testing, learning, failing, and learning more. We need to create a culture that rewards trying and learning. But unfortunately, and I don't want to go on a rant here, but most of the education systems, at least in the US here, do everything in their power to drive curiosity out of our students. Standardized tests, standardized curriculum, standardized classrooms, everybody gets the same treatment, and the result is creativity gets wiped out, which really makes it really hard to embrace that creativity, to find those things that might be better predictors of performance. Right? Because what we want to do is we want to go from descriptive questions about what happened, which is pretty easy because we got the facts. When you start to predict, things get tricky. What are the variables that are better predictors of performance? What are the variables, for example, that would predict my likelihood of catching COVID? Right? Is it my health, my age, my diet, who I hang with, where I go, right? Where I live in the country, what kind of average temperature? Think about all the different variables that might impact my catching COVID. And we want to explore all those. The data science team wants to explore all those because eventually, if we can predict what's likely to happen, then we can prescribe corrective actions to prevent it from happening. But if we can't predict there in the middle, nothing else works. And so this idea of might is very powerful. So our entire data science process is hinged around this idea that we are a scientific method that is seeking to explore, test, try, fail, learn again and again and again. And it isn't just the data science team. The data science team doesn't work by themselves. We bring in the business stakeholders right up front to help us define what it is we're trying to accomplish, to identify and define the KPIs and metrics against which we're going to measure success, to define the stakeholders, the asset models, the decisions, the predictions. We also want to know, by the way, what the costs of false positive and false negatives are. If we don't know the cost of the false positive and false negatives, we can never be certain when our model is good enough. But determining the cost of false positive and false negatives, that is not a data science exercise. That is owned by the business stakeholders who need to spend the time to think through what could go wrong and how do we prevent that and how do we measure that and how do we instrument for that. So that whole art of thinking like a data scientist is built around this idea of building out this hypothesis. It's the hypothesis identification and development process isn't a 2-hour exercise. In many cases, it's a 2 or 3 day process where you go through, you make sure you understand the business initiative and how you're going to measure progress and success. You bring on board the stakeholders. You understand who the business entities or the asset around which you're going to build analytics and what are the use cases we're going to go, the decisions and the KPIs we're going to make, and what data sources might we need, and how do we create these analytic scores that are going to do, and what recommendations do we need to make, and how we're going to map it all together. This is a scientific method approach that cannot be done alone. It has to be done in collaboration with the business stakeholders. They need to be brought in as equal to this process. And the end result, by the way, just so you know, is the creation of what we call the hypothesis development canvas. That basically our data science team doesn't lift a finger, doesn't start applying science to the data until we understand all of these variables here. Because it's going to dramatically impact how quick we build the model and how effective our model is. Are we solving the right problem? I can't tell you how many times I walk into a customer and I go and do a triage in their data science work, and I ask them, I said, "What problem are you trying to solve?" And they're not in agreement. The data science team and the business stakeholders have not agreed upon the problem they're trying to solve. Well, good Lord, how do you expect you're ever going to get anything out of this? Magic? So I'm not a big fan of magic. I'm not a big fan of hope. I like to plan for success. And so the art of thinking like a data scientist and the creation of this hypothesis development canvas in collaboration with the business is critical. But that collaboration requires something. It requires this ability to nurture curiosity. It requires the ability to be able to listen to all people, which brings us to why I'm such a huge fan of design thinking. The entire art of thinking like a data scientist process is chock full of design thinking concepts. I believe design thinking is a great tool. And design thinking really is about learning how to speak the language of your customer. I understand the starting point here. The starting point on this design thinking journey is empathizing with your customers. Now, do you really empathize with your customers? Do you understand what they're trying to do? Do you understand the cost of not being able to do that? Do you understand the benefits of doing that? Do you understand the journey they're going to take to do that? It's about walking in their shoes, defining it, validating, bringing in ideation. All ideas are worthy of consideration, bringing in all the people who can help ideate. You diverge before you start converging on a solution. You don't solution engineer too soon. You want to make sure you've brought in all the different people because you're never certain who might have the best idea on how to solve this problem. Prototype, test, and circle back through here. And there's lots of great tools that we can use from design thinking to help us better understand our customer and what they're trying to do and why it's important. The customer persona that talks about jobs to be done, the gains and the pains. The customer journey map's a great tool. Really forces you to walk in the shoes of your customer as they walk through their journey, trying to understand what they're trying to do, which of the steps in this process are gains, which one are pains. And so that at the end, I can actually construct a solution for them that actually addresses that problem. But here's what I find most powerful about design thinking. It is literally the different side of the same coin as machine learning and data science. The process we go to build out our machine learning and AI models looks virtually the same as design thinking. Now, I will tell you, the world leader in design thinking is Stanford University. And it's not, and part of the reason why Stanford is so good at this is because their design thinking school, they call their D school, their design school, does not sit within any one of the universities or colleges. It sits outside. And every student, whether you're in software engineering, whether you're in nursing, whether you're in law, whether you're in sports, whether you're in business, has the opportunity to learn about design thinking. And it changes how you approach problems. It forces you to be more inclusive. It forces you to be willing to unlearn so you can learn new ideas. And it maps almost one-to-one with how we build machine learning and AI models. So as you can probably guess, I'm a huge fan of design thinking. All of my data scientists have been trained in design thinking. Well, let's talk about the real power here now. So we've kind of set the stage. We've talked about the data science process, how important it is. We talked about how design thinking really sort of unleashes the greatness of the organization's people so that your data and analytics have much more relevance to the problem you're trying to solve. But let's talk about the economics of data and analytics. Think about this. When I first got started in this process, I'm going to back up a second. I want to give away my pain here. So on this journey, when I was at the University of San Francisco, we decided to do a research project on trying to understand the value of data. And I asked my research assistants to go find me an asset on the balance sheet that looks like data. Because I was fascinated and fixated on trying to put data on a balance sheet. That was my goal. Be the guy that figures out how to put it on a balance sheet. That'd be really cool. And so my research assistants went off and did their work, and they came back to me. And one of them, she came back to me and says, "Professor Schmarzo," she said, "I got to be honest with you. I can't find anything that looks like data. And I said, well, explain to me further. She goes, well, data is an asset that never depletes, never wears out, and we can use across an unlimited number of use cases at zero marginal cost. When she said zero marginal cost, I literally, the light bulb in my head went off and I realized, oh my gosh, I have been thinking about this wrong for years. It's not an accounting exercise where accounting determines the value of an asset by what someone's willing to pay for it. It's an economics exercise where the value is determined by how much value I can get from using it. It's not a value in exchange methodology I was interested in. It was a value in use. And when I started applying economic concepts to data, we started getting some of these things like the economic multiplier effect that just jumps up, right? Think about this, right? I can take a data set, oops, wrong way, my customer point of sales data. My sales organization can use that data in promotional effectiveness to drive promotional effectiveness by improvement, let's say by 2.5%. Now, I don't know how much 2.5% might be. Depends on the organization, right? It might be $100,000. It might be $20 million. But I know I can get value from the application of the data to that particular use case. But wait, there's more. My marketing organization can use the same exact data set at zero marginal cost to improve customer acquisition by 2%. And again, I'm not sure how valuable 2% is, but I know it's worth something. And I'm getting it for zero marginal cost. And the same thing on my call center to improve customer retention, or my product development organization to improve new product introduction. You can see what's happening here. The ability to reuse a data set over and over and over again. This data economic multiplier effect is unlike anything we've seen because I get to use it at zero marginal cost. This is a game-changing concept because it really puts the onus on organizations to make sure your data is shareable and reusable. Data silos are your enemy. You have data siloed, you have data you can't share or won't share. That's the great destroyer of economic value. And so the whole approach is based on this idea that on a use case by use case basis, where I know where this is where value is being created by targeting these use cases like customer retention and new product introductions and on-plan operational downtime and retaining freshman students and such. If I target on a use case by use case basis, I will know what data I need to solve that use case and what data I don't need and what analytics I need to build and what analytics I don't need to build. I don't need to build out my entire data and analytics infrastructure to start. I can build up my data and analytics infrastructure one use case at a time, where each use case has a compelling ROI, especially when I invoke this at zero marginal cost ramifications. And it transforms the organization's data lake into this collaborative value creation platform, a term that I got from the IMF when working with them, right? They look at this as being our ability to share and reuse data across the organization is a point of organizational advantage, to be able to reuse this data over and over again and eliminate data silos and orphan analytics. Let's go one step further. Let's talk about orphan analytics. Now, when we did this study, one of the things that came up was that organizations would build these ML models and they would solve a problem. They'd deliver a nice little impact, but it never get reused. And in fact, that ML model over time would drift and decay and would not have any value. In fact, it might generate wrong information at some point in time. And the problem is that the person who built it, Bob, who built this ML model, is no longer working on it. He may no longer be with the company. And so all of a sudden, these ML models that you built to solve a problem and were initially an asset have now become a liability. These orphaned analytics, we call them orphaned analytics, they got built, they delivered immediate value, but never delivered sustainable value. They were not sustainable. And then we have the great Elon Musk, who makes this point. If you buy a Tesla today, I believe you're buying an appreciating asset, not a depreciating asset. Now, wait a second. All of you with your accounting backgrounds are all scratching your head. How in the heck can that happen? You buy an asset, you immediately put it on a depreciation schedule, and you start depreciating it. But here comes Elon Musk and says, no, you're wrong. You're playing the wrong game. If you want to change the game, you need to change the frame. And what he's saying is by virtue of what he has built into his Teslas, the AI learning capabilities, that every mile this car is driven, it's getting smarter, more predictable, more reliable. Now, you need to first understand how AI works. I think probably everybody on here does, but just a quick refresher. AI is very simple. All it does is it continuously learns and adapts based on its interaction with its environment and how you define the AI utility function. And the AI utility function is comprised of the KPIs and metrics against which you're going to measure success and progress. Remember, we talked about that earlier. We talked about that in the very front, right? How important it is as an organization to bring in all the stakeholders so you thoroughly define the KPIs and metrics against which you're going to measure success and progress. Oh, and by the way, the AI utility function and the economic utility function look pretty much the same. But once you've defined that utility function, now the system is going to operate and continuously try to learn. And it's going to bounce, it's going to make mistakes, but it's going to learn from mistakes. It's going to fail and learn. So here's what's going on now. So now you integrate your car with an AI agent that's in there. It's the Tesla FSD, fully self-driving module. It's basically an AI agent. And what it's doing is that car is continuously learning. And here's the interesting thing about this. Even if the agent isn't turned on, it's still monitoring the driver in shadow mode. It's shadowing the driver even when it's not turned on, so it can continuously learn and adapt. Now, that's great, right? That car is getting smarter and smarter. Every time it turns a corner, every time it passes another car, every time it passes a pedestrian, it's getting smarter and it's getting better. But here's the real power. 1 million Tesla vehicles in the world, every one of them learning. At the end of every night, it shovels up all its learnings back to its great Tesla cloud. It learns and aggregates those learnings and then propagate them back to the cars, so that any one lesson that one car has learned, now all 999,999 other cars now learn. Elon Musk is playing a different game, folks. He understands that the law of compounding, if I can make 1% improvements, that if I do that 1 day of the year, at the end of the year, I'm going to have a 37.8x improvement in value, in efficiency, in reliability, in accuracy. It's a game-changing concept that you can build analytics not as one-off orphan bespoken models that are built to solve a problem then forgotten, but you can engineer these things so they continuously learn and adapt. They appreciate and value the more they are used, not depreciate. Let me wrap up here with a couple of slides. We have left some time for Q&A. The economies of learning are more powerful than economies of scale. In knowledge-based industries, the economies of learning are more powerful than economies of scale. Now, we know for the longest time that organizations basically relied on economies of scale to retain their competitive advantage. Mass procurement, mass production, mass marketing, right? Mass distribution. They used economies of scale to build barriers. But what we're learning nowadays in knowledge-based industries, economies of learning are more powerful. That the ability to learn and apply that, incrementally learn, and to share that, to learn, share across the organization, creates this continuously learning and adapting organization. In knowledge industries, the economies of learning are more powerful. And here's the fact. Every industry will soon be a knowledge-based industry. You can't find one that's not going to be. And we need to think differently about how we approach the business when the economies of learning are more powerful than economies of scale. And how do we disseminate learning? How do we learn more quickly? How do we fail and learn? How does failure become a business strategy? That is not how economy of scales companies think. Failure is how you get fired. But in economies of learning economies or companies, failing is how we learn, and failing and learning fast is critical. And if you can embrace this, there are 3 different things that happen when you start looking at the economies of learning, especially around data and analytics. I call this the Schmarzo digital asset valuation theorem. It's my bid to win a Nobel Prize. There are 3 impacts that happen when you take a use case by use case incremental approach to build and learn. There are three things that happen. First off, when you do this incrementally, your marginal costs start to flatten. The data that you need has already been put into your data lake or data mesh, whatever you want to call it. And I'm not building orphan analytics, but I'm reusing my analytics. This is all about how do I reuse, share my data and analytics. So first off, my marginal costs flatten. The second point here, though, is I accelerate time to value and de-risk projects, right? Use case by use case. I'm starting to, if I can reuse the same data, I've reduced the risk. If my first use case takes me 6 months to do, my second one might take 4, my third one might take 2, and all of a sudden I'm doing 2 at a time and 5 at a time. Now I'm reusing. It's almost like a bunch of Lego blocks. Those two effects alone, and the gap between the effect 2 and effect 1, is a compelling enough story that every organization should be embracing this idea that I can share and reuse my data and analytics. The data silos and orphan analytics are the enemy of the organization. But then there's one more effect. If I can build analytic modules, much like what Tesla is doing with their FSD, what Google's doing with their TensorFlow, if I can build analytics that get smarter the more that they're used, that they're continuously refining, learning, and adapting, that what happens is any change, any improvements I make that analytic module ripples back through to every other use case that use it. This is exactly the Tesla story, right? 1% improvements over 365 times has a magnitude change that we can't even imagine. But it requires the organization to think differently about data and analytics. And the reason why we need to embrace an economic approach, because this is an economic powerhouse that allows us to transform our economic value curve, allows us to do more with less, to deliver more healthcare at less cost, to deliver economic growth at less cost. We got caught in this last pandemic, at least in the US here, trying to decide between the economy and health, right? Do we shut down the economy for health, or what do we do? Well, here's the thing, folks. It's not an either or situation. It's an and situation. You can have economy and healthcare if you leverage nanoeconomics, the economics of data and analytics, to drive precision actions to do more with less. Thanks for your time.
Thanks, Bill. Thanks for the presentation. I think that it's very important to know, to recognize the value in data and potentiate the business, because many companies doesn't know the economic value, and maybe the mindset of the leadership impossibilitates the change to improve the company. Okay, now we have QA time. Si tienen alguna pregunta, me la escriben y yo la trato de traducir. O si quieren la pueden hablar y decirlo ustedes. No sé, Fer, Cristian, algunos chicos, ¿tienen alguna pregunta? Okay, questions?
Yo tengo una pregunta. Hi, Bill, how are you? I was wondering, what kind of skills and mindsets should we have as professionals to work with business analytics and keep learning from all this?
Sophia, I love that question. Thank you for asking it. It's something I probably should have talked about. In my class I teach at Menlo and in Galway, one of the modules we have is how do you future-proof your career? How do you make sure that your career is going to survive the next transformation, the next pandemic, the next crisis? I think there are 3 skills that everybody needs to learn. And it's not just my students. I teach my kids this, the same thing. There are 3 skills I think are critically important. Number 1, get comfortable with data and analytics. Get comfortable with looking to make decisions based on data and analytics, but realize that predictions are never 100% accurate. You're going to be making decisions based on probabilities. So number one, you need to get comfortable with the idea that data and analytics can help you give insights to help make more informed decisions. Number two, learn economics. It's all about value creation. I mean, at the end of the day, whatever your profession is, whatever you decide to go into, whatever industry you go into, you have to figure out how to create value. Even if you're an independent worker, independent own company, value is critical, and economics is an underpinning for value creation. And then my surprise one here is design thinking. You need to spend time looking and understanding design thinking. Design thinking is a liberating way to think about how you can brainstorm ideas, how you can embrace a very difficult situation. And instead of saying, well, I can either do this or that, you embrace a mindset that says, well, how do I do both? I'm a huge fan of design thinking. So I think and what I like about design thinking is it's going to force you to think like your customers. You're going to walk in their shoes. You're going to understand the problems they're wrestling with, the jobs they got to get done, the pains, the gains, and the journey they're on. So get comfortable with data and analytics. Get comfortable using data to make informed decisions in a world of imperfect information, especially if we believe social media and how we're being bombarded with far left, far right conspiracy theories. No, right? You need to be logical and understand how data and analytics help you. Number two, you need to understand how value is created. And a lot of the concepts of economics show you and teach you how to create value. And number three, you got to understand how your customers think and walk in their shoes. That's design thinking.
Thank you very much.
¿Alguna pregunta más? Aprovechen.
Yo tengo otra pregunta.
Okay.
Bill, it's me again. I was
you
wondering,
again. I mean, how do you get to ask two questions? Are you bribing people? What's going on here?
Yes, I'm bribing people. I am so sorry, but I'm completely unashamed. Okay, so I was thinking about what you said about the COVID crisis having been approached so in such an inefficient way when it comes to vaccines. Do you think that data analytics would also make governments make more efficient and informed choices?
Oh my gosh, yes. I had a chance to speak to state of California state legislatures on this topic, and I probably didn't make any friends because I gave them a lecture about how inefficient they are, how governments have allowed ourselves to make decisions based on averages. You can probably guess I hate averages. I mean, if you making decisions based on averages guarantees you average results. And so there is a huge opportunity for governments, for nonprofits, for organizations of every size and shape to make much more informed decisions, much more granular decisions. This idea of do more with less, I think as a country, at least in the US here, I mean, we're spending money like we're a drunken sailor, right? We're running up big tabs for this and that. There's a day of reckoning coming. We're going to pay things back at some point in time. It may not be my generation, but my kids are going to be stuck with a big bill, and they're going to be forced to have to learn how to do more with less. But that may be a good thing, because that may force government and our leaders to step back and realize if we can't collaborate and work together, we'll never be able to do more with less. We'll never be able to get down to that ability to make these precision decisions about, where are we doing maintenance on our roads? Who are we, what welfare programs are targeted at what individuals? What about healthcare? And how do we take that healthcare economic value curve that in the US is flattened out? And how do we basically transform that? So yeah, I do think there's a huge opportunity, but I don't think my generation is going to be able to do it. I think my generation has failed. It's up to your generation to pick up the mantle and to run with it.
Thank you, Bill. I agree. In Argentina, we have statistics and information that's very descriptive of our economic problems. So it will be interesting to know and to make an effort to bring all this knowledge into a state level.
Yeah, well, and I will say it's on you. It's now on you to carry this forward. It's on every one of the students out there. It's on every one of us as educators to carry this forward, to be able to really tell and help people understand that we don't have to live in a world where it's either or. That if we apply data and analytics, if we leverage some of these concepts around design thinking and bring everybody into the process, that we can do more with less. By the way, one of the things about design thinking that I think is really a subtle benefit, when you bring in a diverse set of perspectives, not only do you build better models that are more efficient, but more projects die, not from technology, but die from organizational passive-aggressive behavior. The person you didn't bring into the process, who doesn't feel like their voice was heard, right? They're the ones throwing bricks through windows, right? Everybody wants to have a voice. And I got to tell you, we want to hear their voice because we can learn from their perspectives as far as what can we do to better serve them, to do more with less.
Thank you so much.
See, I'll teach you to ask 2 questions and I put it back on you. So now it's your problem. See how smooth I was with that?
Oh my God.
Any questions?
Hi, Bill. Thank you for your time. I would like to know what you think about statistics in data science.
So statistics are important. It's a foundational capability. It's when you learn math, you got to first learn how to multiply and divide and add things together, right? These things all build. Having a solid foundation in statistics is really important. You need to understand statistics. One of the things that becomes really important in statistics, and I still find it somewhat confusing, is understanding type 1 and type 2 errors. Understand the costs of the models being wrong. Now think about that from the perspective of an AI model. We know that, at least in the US here, a lot of the hiring models that are built use AI. And these AI models have a tendency to hire people who look like the people you've already hired, right? There's 2 kinds of errors there. There's the false positives of hiring somebody who you think is going to be good, and you bring them on board and they're not good, and you got to fire them, right? And false positives are actually easy to track because you know who you hired, and you can learn from that hiring not being well, and you can feed that back into your AI model. But think about this. Think about the person you didn't hire. Think about the person you didn't give a loan to. Think about the person the university did not admit into the university. How do you learn from the false negatives? That takes a very creative approach to instrument and go back and follow up. Because if your AI model is not learning from both the false positives and the false negatives, it will suffer from confirmation bias. And the ramification to a business is that what happens is your fringe customers start getting, ignored, and your total addressable market starts to shrink because you're only selling to the same customers over and over again. So there's good economic reason why statistics and understanding the cost of false positives and false negatives is very important to anybody's business in any organization. There's ethical reasons to it. I can stand on and chat about it, but there are business and economic reasons why false positives and false negatives need to be instrumented so your models can continuously learn and adapt.
Okay, thank you, Bill, for your answers.
You're welcome.
Okay, one question from chat. Do you think that we can to accelerate our economic situation implementing ML, machine learning?
Yes, with a caveat. We know that culture is as important here as technology. And building a culture where people feel comfortable and confident to make decisions based on data is critical. Now, here's what that means. Because we're making probabilistic decisions, there's going to be times when we're wrong. When we're wrong, are we punishing or are we learning? What kind of culture has your organization put in place? Now, there's a lot of organizations that when you're wrong, you get fired. But if the economies of learning are more powerful than economies of scale, then we have to put in place a tolerance to learn from failures. Now, just if you just fail and don't learn from it, yeah, maybe you should be fired, right? But the idea is that you need to be able to take intelligent risks in the decisions you make to push the edges so that you can learn. If you're not failing, you're not learning. If you're not failing, you're not pushing the edges. And so I do think ML models can have huge impact, but if we don't address the cultural aspects, if we don't teach people about data literacy, if we don't teach them about some basics and statistics, if we don't teach them about AI ethics, right, then we will fail. We'll build ML models that no one will actually use because they're not comfortable, they're not confident, because the culture doesn't allow them to actually embrace how these models deliver results.
Yes, it's right, because I think that the culture is more important than the application that we could make with data or machine learning, because if you have a great machine learning engineer or data scientist, yes, it's good. But if you doesn't have the right culture, that person doesn't apport anything.
And Professor Luca, on that point, one of the things I like about design thinking in the data science model development process is you never know who's going to have the best ideas. And so you want a culture where all ideas are worthy of consideration, where everybody has an equal voice, where I don't know a lot of time, but I'm going to waste it with a story here. We did a project for a casino, and we had 18 executives in this workshop brainstorming what data they want to do to predict who they gave comps to. If you think about a casino, at least in the US, what happens is if you lose $1,000, they give you $200 back in comps, because they want you to come back, right? They don't want you to go broke. But anyway, the person who had the best idea was a woman who sat in the back of the room. She ran the cashiers and the cash register in the casino, and no one gave her a thought. But when we started brainstorming who are your most valuable customers, she had all these behavioral traits. She says, well, we look for people, when we give them lines of credit, we look for this, we look for that, we get information on this. And she described all the things that she does. And I remember the two executives in the front row. One of them was the vice president of slots. And in casinos, the person who runs the slot machines runs the casinos, because that's where all the profit is. And his name was Buddy. And Buddy stood up in the middle of this thing, turns on, looks at this woman. I think her name was Sally or something. He's like, you know this, you know that, you know this. And she goes, yes, yes, yes. He goes, how come I never knew this? And she said, because you never asked me. So we have to create a culture where people aren't afraid to say, hey, I know something. The movie Big with Tom Hanks, we have to embrace our inner Tom Hanks and be willing to raise our hand and say, I don't get it. Why are we doing things like this? We have better data. So again, I think this design thinking is all around how do you create a culture that unleashes the greatness in everybody. But if we don't do that, then we're leaving all this untapped potential. We're spending so much time talking about machine learning and analytics. We're missing the most powerful asset an organization have, which is people who can learn and adapt. Anyway, sorry, long story.
Yes. The last one, I think that data can also be used to do bad things if it falls into the hands of evil people. What should we aware of as a society? Do you think that we are prepared to avoid it?
Great question. Great question to end on too, because it does raise a big challenge. We have an option. We can either have government build regulations to try to stop it, which we know almost always ends up in being a disaster, or we can educate our people to watch out for it. Now, for example, one of the things in our class, I have the students get up and I have them pull up their phones, and if they have an Android phone, there's like 4 or 5 applications. Do you have this application? And most times they do. They're games. And I say, do you know that this company is located, not to pick in any country, but they're located in China, and they're actually pulling off all your email, all your contacts. They're pulling off all your tweets. They're not just pulling off what you do in the game. They're actually mining the entire system. That's on you as a user to be aware. When you download something to your phone, and we all do it, oh, cool new game, I'm going to download this thing. You need to understand what that environment's doing. So I think it's on us as instructors, as teachers, as parents, to make certain that our students and our children and sometimes maybe even our parents understand that what's going on here is there is no free lunch. And so you need to be very aware of how some organizations are using it for nefarious reasons, and how some organizations like the Googles and Facebooks are using it for their own purposes that may not be in your best interests. Again, it's on you.
Yes. Yes. All right. Thanks, Bill. Thanks for your time, and it will be great that we would do the next year.
Yes. I will send you the presentation so everybody can have it. And
yes,
if you have questions, please reach out to me probably on LinkedIn. I don't hang on Facebook for obvious reasons. I think Facebook are not my friends.
Okay, me neither. Okay, see you. Thanks for your time.
And thanks for recording this. I greatly appreciate that. Take care, everybody.
Yes.
Data,
Thank you, Bill.
do more with less.
Thanks,
Great.
Bill.
Yes.
Thank you very much.
All right. Bye-bye.
Bye-bye.
Bye-bye, Bill.
Thank you.